Hey guys, Miss Peterson here. Today I'm going to be showing you guys how to use Google Sheets to graph some data. My data was collected from spring 1 of the pHet simulations about mass and strings. I measured the distance that the string was stretched with various masses on it. Okay, cool? Okay, cool. So, now I have my data. I have my masses and I have my distance stretched. And I want to know the force of gravity. Well, the force of gravity on any object is mass times gravity. So I'm going to do equals. Equals says Excel, hey, do some math. My mass, which is in that cell, that number right there, I just click on it, times, okay, it's that little star above the 8 number, times 9.8, the acceleration due to gravity. And when I press enter, I get 0.49. Then I can just go to this little blue square in the corner and drag that formula down. Oopsie, dragged it down too far. Just delete that one. Okay. Now you'll see this cell is a 3 times 9.8, that mass, and this one is a 4 times 9.8. Now for a spring, when a spring is in equilibrium like this, the restoring force, the force pulling up, equals the force of gravity pulling down. Okay? Because gravity's pulling down, the spring's pulling up. Restoring force equals the force of gravity. So this cell equals that cell. And I can just do the same thing for there. Okay, now it's time to graph. I want to graph my restoring force versus my distance stretched. So I'm going to go ahead and click and drag to select my distance stretched. I'm on a Mac, so I hold the Command key to select that data as well. Okay? If you're on a PC, you hold the Control key to select those two different columns. Or because they're the same, we could just select it like that. Now we're going to go to Insert, and we're going to insert a chart. The default that it will enter is a bar graph, but we don't want a bar graph, okay? Bar graphs aren't very useful in science class. We always pretty much want a scatter plot, okay? So I'm going to do my scatter plot, and you should see 3 dots pretty neatly in a line. It's linear. We know that, okay? So now we just need to customize my graph and add all of my data to it. So you can customize the style, the background color, and the font. And every good graph needs a title. For this title, it's the restoring force versus the distance stretched. So that'll add that up there. I want to add my horizontal axis, which is my distance stretched in meters. And my vertical axis title is my restoring force in newtons. Okay, so now we have what looks more like a good graph. We could expand it a little bit if you wanted. If, say, you wanted it to see 0, you could set the minimum value to 0. Okay, I like to do that just so I have a better sense of where things are at. Okay, so that makes it so you can see a little bit more on the graph. Now we need our trend line, okay? Trend lines are super important. So we're going to go to our series and we're going to say, hey, we want a trend line. It'll give us this nice linear trend line so we can see the relationship in our data. Now we can also describe that using math. So we're going to label our trend line with the equation. Okay, so it says that the equation is 9.8 times the x-axis, so y, the restoring force, equals 9.8 times the x-axis times 4.4 times 10 to the negative 16. That's a really small number. It's basically 0. When it's such a small number, you can ignore it, okay? If you look at this graph and remember your y equals mx plus b, okay, the y-intercept is basically 0. So we're just going to ignore this number here, okay? So that means that our restoring force always equals 9.8 times our distance stretched. We can use that to solve for other things. We can look at the distance stretched of maybe these mystery masses. Okay, this mystery mass stretches at about an 11. Okay, nope, sorry, about a 15 or 16. So I know that my distance stretched, which is my x-axis, times 9.8 will give me my restoring force. Okay? So we can use that to figure out all sorts of things. Now, if you need to do anything else in your graph, like say answer some analysis questions, you can just type answers right in the cell. Look at my correct answers. Now, when you're ready to turn this into me, what you're going to do is you're going to go to Jupyter Grades. I'm going to borrow somebody's Jupyter Grades that I know won't care. You're going to go to your physics class and the mini lab Hooke's Law, and it says turn in a PDF Juno Docker link. And I'm going to say select from Google Drive. I can't do it because I'm not on my own one, but you're going to select from Google Drive, and it will allow you to turn in this assignment. Please title it as your last name and then Hooke's Law when you turn it in. Okay, cool? Okay, cool.